many national and international papers, and he has visited almost 7 countries. So it's a proud privilege for us to have Dr. Murthy garu with us. And I request whenever we need some resource in communication engineering, we use it to rely upon Dr. Murthy garu only. His supervisor is so renowned person. He has written Springer books also. So he is so lucky to have such a qualitative supervisor. So therefore, I request Dr. Murthy garu to present his session on wireless communication.
Thank you very much, sir. A very nice introduction of me.
Sir, always signals communication and signal processing. He used to teach analog communication, digital communication, wireless communication, coding theory, and what all the communication subject. We first give preference to Dr. Murthy garu only. Thank you very much, Dr. Murthy garu. Please start your session.
Yeah, thank you very much, sir. Srinivasa sir. First of all, very good afternoon, one and all. Respected head of the department, KCB Rao garu, and respected Professor C.S. Srinivasa Rao garu, Hema madam, other colleagues and participants. A very good afternoon, one and all. First of all, I would like to extend my sincere thanks to Srinivasa Rao garu, who has given me opportunity to serve my institution as well as my department. Thank you very much, sir. I am grateful to you. I'm very glad to be with you, sir. Thank you. Thank you, one.
Thank you.
Sir, I'm going to start this session, sir.
Please.
Yeah. Actually, as a part of the two-day FDP two-day workshop, in this afternoon session, I'm going to speak on security in wireless communications. Actually, my point of discussion is here. So, what are the factors influence the security, and particularly in now we are going to deal with the 5G system. So, security is a very important parameter. I'm going to give brief idea about the security and other parameters. In this regard, mainly my presentation includes introduction about digital communication system. Why? Because wireless communication system is a digital communication system. We should know some important points. What were those were proposed by Professor Shannon. Later, some brief idea on wireless channel model. Later, next we are going to discuss about the security. What is the importance of security? And the last one we are going to discuss on the physical layer security, and what is the importance of physical security for particularly 5G wireless systems. I'm going to give, finally I'm going to give some future challenges also. So yeah, this is my presentation. First of all, regarding the digital communication system, because wireless communication system is a digital communication system. So we should know the basic fundamental principles proposed by Shannon at 1948. Actually, before the Shannon, also some of the pioneers worked for to decide the roadmap for digital communication system. But they worked for specific applications. Particularly when it comes to the Shannon, what he has given complete roadmap with the help of earlier works and his inventions. He has given roadmap for the digital communication system. That's why Claude Shannon named as the father of digital age. Mainly proposed information theory. So one of the important key concepts in information theory is channel capacity. Mainly, the Shannon's paper has 4 concepts. So in the last point, if you look at this slide, so during the interview with Fano, he's another professor of MIT. He shared the Shannon idea, what Shannon said. So to make the chance, finally, to design a reliable communication with error as small as you wish. As small as you wish. We are trying to reduce the error rate. Actually, when you say optimal system, if you transmit 10 lakh bits, if you get only one error, then it may be reliable communication system. So Fano said his words. Nobody had ever thought of that. How he got that insight? He means Shannon, and how he even came to believe such a thing, I don't know. But almost all modern communications engineering is based on that. That is more important. What we are enjoying today with the digital communication systems, particularly. So that is the contributions by Shannon. Actually, presently normally we used to discuss the generations, different generation 1G, 2G, 3G, 4G, and 5G. Now we are trying to use the 5G systems. At some places those systems are available in future, in near future. So 5G in operation, 5G will come in operation. So particularly only 1G is analog communication system. From 2G onwards, all are digital communication system. So all the modern communication system based on the Shannon principles only. That's why I'm going to give some insights in Shannon principles, what Shannon proposed. So mainly there are actually four major concepts in Shannon's paper. First one foremost is the channel capacity and noisy channel coding theorem. So channel capacity is one of the important parameter. Actually channel is nothing but it's a media between the transmitter and the receiver. Every channel, it may be wired or wireless. It has some capacity. So suppose if you want to design a reliable communication system or error-free communication system, you need to follow the for this Shannon has given some guidelines. For example, the actual Shannon formula is C is equal to B into log base to 1 plus S by N. That means B is the bandwidth and S by N is signal to noise ratio. And the capacity of a channel is proportional to bandwidth and logarithmically proportional to signal to noise ratio. If you have more bandwidth, so you can offer more rate. So finally, our aim is to develop a reliable communication system. So our error-free communication system, our transmission without error. So Shannon says that based on the formula, what he proposed. So if you design a system with no errors, that is possible if the limit is less than the C, then only transmission with no errors is possible. Suppose if you design a system more than the limit, definitely their error-free communication is not possible. What Shannon proposed, error-free communication is not possible. But then you can say, so all of you aware that channel coding techniques. I can use most powerful channel coding technique to design error-free communication system. But the limit is above the Shannon limit. But what happens if the limit above the Shannon, if you design a channel, if you may use the advanced channel coding, but it leads to communication becomes slow and complexity will increase. So final conclusion is from the channel capacity, better to design error-free communication with the limit should be below the Shannon's limit. That is the conclusion. Only the formula will give that much of information. Suppose if you, for example, this is an example. Today, if you take a CD, scratch it with a knife, and play it back, it will play back perfectly. That's thanks to the noisy channel coding theorem. So here the first one is the channel capacity and noisy channel coding theorem. So mainly Shannon paper has proposed four concepts. The first one we have completed just now, channel capacity and noisy channel coding theorem, particularly designed for wide Gaussian noise channel. And the second point is the digital representation. Digital represent any message, any source information. For example, it may be voice, or it may be video, or it may be image. Normally, what we are doing to process our digital system, we are trying to represent in ones and zeros. So what Shannon says that once you represent ones and zeros, it will be recovered. It will be recovered at the receiver end. So once and the message is irrelevant to the transmission. Here, video we are representing ones and zeros. So voice it may be represent ones and zeros, and that means transmission irrelevant to the source information. That is what we call digital representation. Next, efficiency of the representation, that is source coding. Source code. Actually, source coding is synonym for compression, data compression. Mainly source coding, what we are doing in source coding, we are trying to represent actual data in as small as possible so that we can save power and bandwidth up to some extent. So what we are doing is, suppose for example, if you take voice as a source, voice, suppose if you want to transmit voice from here to somewhere else. So actually to recover your original voice at the receiver end, no need to send all voice information over the channel. With some information, we can recover the original at the receiver end. That means this voice may be said to be, it may contain a lot of redundant information. So that redundant information is nothing but without that information also, you can recover the original message at the receiver end. So we can do some compression. So based on that, application will decide. So on what compression? Again, compression, there are two types, lossy and lossless. I'm not going to discuss that one. Mainly in source coding, we are doing some compression. So the examples of source coding is JPEGs, MP3, and zip files are only some examples. For example, for source coding, mainly there are Shannon and Fano has proposed one code. Later, the Huffman, who is a student of Fano, so he also proposed Huffman coding. So these are the examples for Huffman coding. Huffman coding is one of the best source coding technique. Final, entropy. Entropy and information content. So one more important point here is Shannon has proposed information theory. So actually, what is meant by information theory? So information theory, normally, if you look at the name itself, information theory, people may thought that it is related to information. Actually, information theory is not about information. It is nothing but transmission of information. Information theory is nothing but transmission of information, or we can also call it mutual information. So that everybody should understand. Next, the following entropy, how you define average information content. Normally, how you measure the information. Information will be measured with respect to randomness. If you have more random information, then the information is more. So that is about the brief discussion on the word proposed. These are the inventions proposed by Shannon. So next, information theory is nothing but information provided by something about something. Information is nothing but information provided by something about something. It was a statement made by the Fano during the interview. Work on information theory tend to focus on three main areas of application-based research: spectrum technology, source coding, and channel coding. Source coding, channel coding, just now we discussed. In source coding, what we are doing some compression, we are removing the redundancy. Finally, we are representing the source information in an effective manner. So in the channel coding, what we are doing, we are providing some immunity against the noise, because when signal is propagating through the channel, it will be undergo some distortion due to presence of the noise. So to provide immunity against the noise, in the channel coding we are providing some immunity. So how you are providing? We are adding some redundancy to the channel signal. So in source coding we are removing redundancy, and channel coding we are adding some redundancy. Now coming to the spectrum technology, one of the important technology, particularly 3G CDMA is a spectrum technology. We are spreading over narrow band over wide spread of frequencies. So one of the major advantages of spectrum is that it provides immunity against jamming, intentional jamming as well as unintentional jamming. That is the major advantage of spectrum technology. That's why presently it was proposed. Initially, it was proposed for military application. Later, it extended to CDMA because it may consume a lot of bandwidth. But it has an advantage, particularly in the jamming. So this is about the information theory. Finally, before going to the next, yeah, okay, here, yeah. Once actually Shannon proposed his invention in 1948, he proposed the importance of the source coding as well as the Shannon coding. But at that time, people didn't know the real importance of the channel coding. Actually, channel coding comes into picture around 1980s. But Shannon proposed the channel coding in 1948. Why? Because people thought that at that time people were taught that establishing reliable communication is nothing but simply blast the information with a high power, and signal transmit with the high signal to noise ratio. Then it will provide automatically error free. And people thought that to design error free communication system, that may be the solution. But once the space communication comes into picture, here, so to blast the signal at high power, high signal to noise ratio. So particularly when you are dealing with the space communication, it has some issues. Some issues were raised, because here the point is, because power is very expensive in space, but bandwidth is plenty at space. So the generation of power, the weight of the power supply, and that's when the industry and the research in general began to think much more seriously about the communication in the presence of noise. Space changed the entire, and that means, so these are the generation of power and weight of the power supply. These are the drawbacks when you are dealing with the space communication. So at that time, people may thought that what is another alternative. So then immediately they look at the channel coding. Channel coding. So channel coding, that what he is saying much more seriously about the communication in presence of noise. The best option is the channel coding. So finally, throughout the background of our story, Shannon has been there. His limit pulling the trajectory of information theory towards ever increasing performance. So based on the Shannon principles, so all the modern digital communication system were built. So these are the basic things. Now I am moving to the wireless communication system. Particularly, I am going to concentrate on the wireless channel. So now coming to the wireless communications. Wireless communication has evolved significantly over the past several decades to meet ever-growing demand for high data rates over wireless media. Particularly if you take the mobile, presently around, according to some survey, 1.2 billion mobile phones are using in India. More than that, I think 1.2 billion, not million. So such a kind of wireless systems you are using. So systems have been designed for indoor applications and outdoor applications where the mobility is a very important aspect of system specification, particularly mobility. So one of the key elements in the design of such system is understanding the characteristics of wireless channel. So that is more important here to understand the characteristics of wireless channel. So as opposed to the typically static and predictable characteristics of wired channel, the wireless channel rather dynamic and unpredictable, which makes an exact analysis of wireless communication system often difficult. So in recent years, optimization of wireless communication system has become critical with rapid growth of mobile communication services and emerging broadband mobile internet access services. So these points will be helpful to you to get the importance of the wireless communication system nowadays. In fact, understanding of the wireless channels will lay the foundation for development of high performance and bandwidth efficient wireless transmission technology. So now I think I'm going to discuss few points on the wireless channel because if you model wireless channel perfectly, definitely RLP communication may be possible. So if you look at this slide, so this is the transmitter receiver. So receiver may receive the signal line of sight along with some other elements also. So and that means mainly signal may be affected by the physical environment. Signal may be affected by the physical environment. That means the propagation of model, the propagation of model for the wireless channel is characterized by a mainly path loss, multipath fading, and Doppler spread. And Doppler spread, if there is a relative motion between the source and observer, that leads to some that is nothing but Doppler spectrum. All these characteristics, particularly path loss, multipath fading, and Doppler spread, all these characteristics are affected by the physical environment between the transmitter and receiver, as well as system dependent parameters such as antenna height, antenna beam width, antenna polarization, and mutual coupling between the multiple antennas. Path loss characterizes the attenuation between the transmitted and receiver signals. This is typically based on the physical phenomena like absorption, diffraction, scattering, reflection, and refraction. So fading is a phenomena which occurs when scattering environment between the transmitter and receivers varies with the time. She also finally signal undergo fading. So you can observe here reflected ones. And along with the line of sight signal, along with that some other delayed version of the and copies of the original signal. These are the delayed copies of the original signal due to physical environment effects introduced in the physical environment, particularly reflection, refraction, and diffraction. So no need to explain reflection, refraction. If you see this slide, you may understand the points. So normally, in contrast with the additive white noise, fading also signal degradation that is characterized by the non-additive signal disturbance in wireless channel. Fading may actually here also clearly shown, yeah, path loss and shadow fading and multipath fading. Fading may either due to mainly multipath propagation, referred to as multipath fading or shadow fading from obstacles that affect the propagation of radio wave referred to as shadow fading. Just I'm going to brief about all these things. So I'm not going in detail. I'm not going to discuss mathematical models. Simply, at least, so what are the impairments in the channel, wireless channel, when you are dealing with the wireless communication system channel is the important one. So how the signal affect, that's the point I'm going to discuss. Meanwhile, spatial channel models for multiple communication system report MIMO is proposed to combat the effect of fading. So other techniques also proposed. So this is about the basic introduction on the wireless channel. So finally here, a close approximation of attenuation due to multipath fading in wireless channels can be done by relay fading and Retian fading. Normally channel wave model as a Retian if there is a line of sight path signal is available. If you look at this slide, so actually there is a line of sight. Majority of the wireless communication systems may not be line of sight. If there is no line of sight signal, then we have to go with relay fading. So this is how channel can be modeled. Other models are also there. So this figure classifies the type of fading channels. Fading channel, large scale fading, small scale fading, and I'm not going to discuss all these things. So just given some idea what about fading. Fading is mainly due to multipath effect, and the signal may travel particularly in urban environment, dense environment. So the signal receiver may receive along with the line of sight signal some other copies of the delayed version of the signal due to multipath effect. So these all will be combined at the receiver. Now to get back the original signal, receiver is able to recover the information from this distorted version of the original signal, distorted version of the transmitted signal. So with this, I'm moving to the wireless system security. So the ever increasing demand for private and sensitive data transmission over wireless network has made security a crucial concern in the current and future communication. Particularly nowadays, all the applications like banking sector and health sector and all other applications, we are going to use the wireless communication system. So suppose somebody may try to stolen the data sometimes. So we need to concentrate on the security, particularly in recent days from the last decade. So the people are showing interest towards security, particularly wireless communication, because wireless media is different from all other medias. So securing communication is a challenging task. To address this challenge, scientists and engineers have come up with improved cryptographic algorithms. With the rapid progress of computational devices, the current cryptographic methods are already becoming more unreliable. So in recent years, wireless researchers have sort of new security paradigm termed physical layer security. Here, first I'm going to discuss about what is cryptography, what Shannon proposed the communication of secrecy. Later, we were moving to the physical layer security. So next, one by one, we will discuss. Yeah, first of all, crypto. This is Shannon has proposed a theory of secrecy, and it's a theory of secrecy. Here, cryptology, hidden word. So cryptography, it's a code making. So, and the cryptanalysis code breaking. So from the graph, from this you can understand. So, and that means adversaries or eavesdroppers may try to break the code always. So we need to develop the code which is not breaking, and that means unbreakable code. Unbreakable code. Yeah. Yeah. What are the goals of cryptography? Mainly, the goals of cryptography are secrecy and authenticity, particularly. Secrecy. What is meant secrecy? Concerned with the who has access to or can read a legitimate messages. Legitimate messages. So secrecy is nothing concerned with who has access to or can read legitimate message. So mainly secrecy deals with the safeguarding the future by ensuring that only authorized recipients will be able to gain access to read a legitimate message. So you can understand directly. So that is what we call secrecy. And the second goal is authenticity. So authenticity concerned with who can create a right legitimate message. Who can create a right legitimate message. Authenticity deals with the protecting the past by ensuring that the creator or author was entitled to create or write the message, ensuring that the contents of the message have not been altered. So you can understand secrecy and authenticity. Particularly, these are the goals of cryptography. Well, actually, this is the schematic proposed by Shannon in communication theory of secrecy system. Actually, regarding the cryptography, mainly there are two kind of basically based on the encryption, two kind of cryptographic techniques based on the encoding schemes. So there are two categories. One is the symmetric, second one is the asymmetric. Symmetric means here, suppose before going to the first two, let us discuss on this system. Here, schematic of general secrecy system proposed by Shannon. Here, the message M. Here, to develop the reliable system, reliable system, the message M and the key. These are independent random variables. These are independent random variables. So this key is common to both at the transmitter end as well as the receiver end. Only somebody attacker will try to get the information only from the cryptogram. He tries to get the information eavesdrop. So that's the meaning of this one. So that information also clearly shared here. Shannon's schematic, a general secrecy system makes the following assumption crystal clear. The message M and the key the key K are independent random variables. The sender and the receiver both know the key. The attacker knows only the cryptogram E. So, we consider only that is ciphertext only attack is assumed. The receiver is able to recover the message M from the knowledge of the cryptogram E and K. No assumption is made about who generates the key. So that is about the Shannon's schematic of general secrecy system. Mainly here in cryptography, what happens is that if the transmitter and receiver encryption and decryption, if you are using the same key, it comes under symmetric. Suppose if you are using two keys, it comes under asymmetric. And suppose two keys are particularly important. It may provide additional security when compared to the if you are using same key. But under one key we are using a transmitter and another key we are using at the receiver end in the asymmetric point. But these two keys are mathematically related. There is a relation mathematically related. That's why, and that means that two codes we are calling as a public and private keys. But those are not exactly same. But one is related with another. Mathematically, one is related with another. So like that, we can classify into two categories: asymmetric, symmetric, and asymmetric. Yeah. So next, what is meant by unbreakable? Shannon has defined unbreakable. To Shannon, a cipher is unbreakable in a ciphertext only attack if it provides unconditional security. If it provides unconditional security. Unconditional means that no matter how hard or how long the attacker works, no matter how hard or how long the attacker works, he or she can do better than to guess the plain text by best guessing the rule that she would use without having seen the ciphertext. Yeah. Shannon's 1949 definition: a cipher provides perfect secrecy against ciphertext only attack if the plain text and the ciphertext considered as random variables are independent. If the plain text and the ciphertext considered as random variables and that are independent. There is a definition provided by the Shannon. With this brief on the security that proposed by Shannon. So next, countering security threats. One of this security threat countering one technology cryptography. Second one is the spectrum. Third one is the physical layer security. So in cryptography, at higher layers of the protocol stack, particularly security is provided at higher layers. There are 7-layer OSI model. At higher layers, we are providing some security based on the limited computational power at the adversary. Actually, nowadays, a lot of very good cryptographic techniques are available. But suppose if you that computational complexity that requires more power. Suppose if attacker can if the attacker can afford that much of power and other thing, they can decode. But many times it is not possible. Next, the second one is spectrum technology. Example, frequency hopping and CDMA. At the physical layer, we are doing at the physical layer based on the limited knowledge at the adversary. Adversary means attacker. Limited. So particularly physical layer security we are doing at the physical layer. No assumptions on adversary computational power. No assumptions on adverse available information. Probable and quantifiable in bits per second. Implementation using signal processing, communication, and coding techniques. Particularly, a lot of advanced coding techniques are available. Those will be useful to provide the security. Yeah, this is about the physical layer comparison of cryptography and physical layer security. So next, what is meant by physical layer? Physical layer is the lowest layer of the OSI model. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Due to we are doing physical layer. At the physical layer, the bits are transmitted and received. It is the bit stream physical medium methods of representing bits. That is about the brief on the physical layer. So next, fundamentals. Now we are moving to the fundamentals of physical security. So up to now we had a discussion on a cryptography and a brief on what Shannon has proposed. So now in OSI model, the physical layer of layer 1 is the first lowest layer. It's commonly abbreviated as physical layer. The name physical layer can be a bit problematic. Many people who study networking get the impression that the physical layer is only about actual network hardware. Actually, physical layer contains definition of hardware specifications, encoding and signaling, and data transmission and reception, physical network design. So mainly physical layer may contain these are these 4. So this is again layer structure, transmit and receive. We are doing at the physical layer. Now, what are the solutions? Some of the solutions of CDMA, OFDM, and MIMO. Actually, earlier we discussed spectrum that is coming to CDMA. And the OFDM is another technique to provide security to provide a security. Actually, my student presented a paper in one IEEE conference. So we have designed a security code for the underwater acoustic channels. So particularly in underwater, we are using, instead of using electromagnetic, we are using acoustic signals. So OFDM with turbo code, we have provided some security. We have proposed that was presented in IEEE paper. Second, OFDM is a multi-carrier technology. Mainly the 4G, particularly 4th generation techniques, mainly depends upon the OFDM and MIMO. wireframe, orthogonal frequency division multiplexing. I will say one example. Wireframe, what is the basic comparison with the wireframe and single carrier communication system and single and multi carrier communication system? Suppose in our house, if you take tap and shower, suppose through the tap and shower, same amount of water is coming. For example, if you try to stop the water flow, if you put a thumb at the tap, what happens is the total water will be stopped. That is the example of single carrier system. Then if you look at the shower, if you try to stop the water, what happens? With the thumb, you can stop 2 to 3 holes, water coming from 2 to 3. So remaining will be, as the water will come through, remaining as it is. So that is the advantage with multi-carrier system. So wireframe has a lot of advantages, but it has one disadvantage, that is peak to average power ratio. So normally what happens is, just I'm going to brief about wireframe. It's a very important technology, and in 5G also we are using wireframe and its combination. So for wireframe, it has made one of the major disadvantages, peak to average power ratio. So normally any multi-carrier signal is suffering with large peak to average power ratio. And if you take the peak ratio of peak power to the average power, particularly any multi-carrier signal, so if you take the ratio peak power to the average power, suppose that is large. Due to the large peak to average power ratio, normally at the transmit and signal is propagating to the high power amplifier. Normally high power amplifier is a non-linear amplifier. Because of high peak to average power ratio, when signal is propagating to the high power amplifier, it undergoes distortion. So that's why last 20, I think 2 decades, or I don't know exactly. So a lot of techniques have been proposed, particularly for reduction of PFR. Still, many techniques are proposed based on the deep learning techniques. Recently, deep learning and neural networks based techniques also proposed mainly to reduce the PFR. So because wireframe has a lot of applications, particularly MIMO, multi-input, multi-output. Particularly, we are exploiting the spatial diversity here. MIMO, multi-input, multi-output. So now in 5G we are using massive MIMO. Normally, initially 2x2, two transmitting and two receiver antenna we are using, and mainly in MIMO, spatial diversity and spatial multiplexing we are exploiting. That's the point. MIMO, multi-input, multi-output. So with this, these are the solutions for physical layer security. Yeah, in virtually all communication system, the issues of authentication, confidentiality, privacy are handled in the upper layers of the protocol stack using variations of private key and public key. We were discussed just now. What is meant by private key and public key? Particularly it with the asymmetric systems. And that means both the transmitter, for encryption, different key we are using, for decryption, different key we are using. But both are related with the mathematically, that's what we call private key and public key. So here the issues of authentication and confidentiality and privacy are handled upper layers of the protocol stack, not at the physical layer, particularly crypto systems, upper layers. So while computational security has clear track record of proven effectiveness, it may be difficult to implement in some emerging network architectures. So for instance, while noise and fading are usually treated as impairments in wireless communications, information theory results show that they can be harnessed to hide the messages from potential eavesdropper or authenticate device without requiring a shared secret key. That means actually with advanced techniques, coding techniques and other techniques, what we are doing to what are available now, if you use those coding techniques also provide security. They are providing immunity against the noise, as well as they can also provide the security. So that is advantage with the present techniques. So the physical layer of wireless communication should be considered as unique and different from physical layer of other communications. This is one of the important point. The physical layer of the wireless communication system should be considered as unique. Why? Because it is time varying channel. Wireless channel is a time varying channel. It is unique and different from physical layer of other communication systems. You should note down this point. Why? Then you can understand why scientists are looking at physical security at physical layer. So unlike the traditional cryptography approach, which ignores the effect of wireless media, physical layer security exploits the important characteristics of the wireless channel. physical layer security exploits the important characteristics of wireless channels such as fading, interference, and noise for improving the communication security against the eavesdropping attacks. Mainly, this is the second important point. So, physical layer security exploits the important characteristics of wireless channels such as fading, interference, noise for improving the communication security against eavesdropping attacks. So, this new security paradigm is expected to complement and significantly increase overall communication security for future wireless networks. So mainly there are generally cryptographic methods are used for security purposes. However, they have some limitations like high cost and computational complexity with randomness, in which wireless networks are also unsafe for the public wireless networks because wireless medium is a broadcasting media, so it is somewhat unsecure. Different approaches used for design and analysis of physical layer security techniques I am so these are the techniques available. I am not going to discuss in detail, just I would like to share the what are the techniques available or what are the approaches available for physical layer security. Information theoretic approaches, signal processing approaches, game theoretic approaches, and graph theoretic approaches. So one of the benefits of physical layer security is to amenable to a precise and quantitative analysis of secrecy in information theoretic framework. Again, actually, Shannon's cipher system and perfect secrecy. Actually, these points we have already discussed, but the terminology may be different. We will look at in 1 or 2 minutes. We will complete in 1 or 2 minutes. The study of confidentiality in information theory was pioneered by Claude Shannon using model of cipher system illustrated in figure. Actually, earlier system completely proposed by Shannon. Later, it was modified. So, yeah, used the encoder, used upper. We are using same key. He is the attacker. Yeah. In this objective is to communicate a message reliably from transmitter relais to a legitimate receiver Bob, while maintaining the message secret from the perspective of an eavesdropper who intercept all transmitters. Just 1 minute, 1 moment. Yeah. To help guarantee the secrecy of a message, Alice and Bob have access to shared random key unknown to Eve, which can be used to encode the message into a code word and decode the code word back to the message. This we have already discussed. So with this, the fundamentals of physical layer security completed. Mainly, we focused on the why we have to look at the physical layer security. Already cryptography, a lot of advanced cryptographic system techniques are available. So why you have to go with the physical security, particularly when you are dealing with the wireless communication system, because it is a time varying channel. So it also based on this property, what it exploits the physical nature of the that what we are studying just now. Mainly, physical layer security exploits the important characteristics of wireless channel. There is advantage with the physical layer security, providing security at the physical layer. Now we are moving towards yeah, physical layer security approaches in 5G wireless networks. Actually, these techniques are already proposed. I'm going to present what are the physical layer security for the 5G networks. Final on the last slide, I'm going to give some idea of the future challenges. In recent years, wireless mobile communication has experienced tremendous growth in software applications. Various electronic devices are introduced in large density with advanced features that lead to increase in data traffic rapidly. Fifth generation wireless network is a key enabler to meet the requirements for various wireless applications that also allow communication beyond reach. 5G wireless services are capable of providing cost-effective, flexible, and convenient speed with reliable connectivity. People expect full faith in wireless networks for transmission of their crucial as well as the private information like debit card, credit card, e-health data, and so on. So, particularly, somebody will try to stolen this data. We need to provide the secure. The communication link should be secure. So this broadcast nature of the wireless data transfer, this broadcast nature of the wireless data transfer results in a critical drawback concerning its privacy and secrecy. Thus, the security in communication is a significant concern, particularly in 5G wireless networks. Therefore, PLS means physical layer security. PLS is adopted as it may overcome all the limitation of previous approaches. Primarily, PLS is mainly focused on the secrecy capacity of a propagation channel with information theory fundamentals. PLS makes use of physical layer properties of communication system, such as noise, interference, and time varying nature of the fading channels. So, particularly some of the promising 5G technologies like millimeter waves, non-orthogonal multiple access is one of the important technology, particularly for the 5G, and a massive multiple input, multiple output, massive MIMO, and they may use the 64 by 64, 128 by 128 like that massive structure they may use. So, lot of to provide the to improve the performance of a system, to improve the overall performance of a system in terms of immunity against the channel impairments and also security. The next one, coding of physical layer security, heterogeneous network, full duplex technique, etc. So security in data transmission is essential to employ these technologies in the system successfully. Secure communication will be possible if we perform data security during the first stage, that is at the physical layer. So the basic idea behind physical layer security is to improve the signal characteristics of the intended receiver and reduce the same for the eavesdropper. So the basic idea behind physical layer security is to improve the signal characteristics of the intended receiver and reduce the same for the eavesdropper. Yeah. As the first one, there are 6 techniques have been proposed. So one by one we will do. I'm going to brief just what is the importance of physical layer security at coding. Although the first physical layer security code appears around 1970s to design explicit security codes which can be used in practical communication system is still challenging. Actually, 3 important physical layer security codes, including low density parity check codes, polar codes. Actually, earlier also, I made a statement that we presented one paper that is FDM based. We were used turbo codes for particularly 5G applications. These are the possible codes, LDPC codes and polar codes and lattice codes. So these are all called 5G codes, low density package. So physical layer security we can provide with the help of the coding techniques, mainly these 3: polar codes, lattice codes, and LDPC codes. A lot of advancements development are happening in polar codes, and modifications are proposing. So with advanced techniques, we can provide the required security. Next, the second is the massive MIMO. And that means here massive, not a 2 by 2 or 4 by 4, 64 by 64, 128, 128 by 128 like that. Deploying large antenna arrays significantly increases the spatial dimension of wireless channels. Spatial dimension of wireless channels. So it exploits the extra spatial resources to effectively combat the eavesdropper and guarantees the secure communication at the physical layer with massive MIMO. But definitely complexity and other parameters also which come into picture. But particularly for 5G applications, this may be the one of the best solution, massive MIMO. So both passive and active eavesdropper scenario are described. What is meant by passive and active attack? Passive attack and active attack. Active attack is nothing but directly if you transmit information from source to destination. Eavesdropper passive attack is nothing but information will be altered and actual information may be modified. That comes under active attack. Active attack is nothing but information may be modified. The content may be modified. So passive attack is nothing. Passive attack is nothing but eavesdropper may listen the information and based on the available information, he may propose some. That information may be used for some applications, some what we call some applications, some other applications. Yeah. So directly modify, if you direct content will be modified directly, then it comes under active. Otherwise, it comes under passive. So next, third one, millimetric waves. So manu 5G application normally 30 to 300 gigahertz is planned. So one band 30 to 40 gigahertz may be proposed one for one band. And the second one may be around 60. I don't know exactly. So millimeter wave communications. Abundant spectra within the high frequency band may result in significant different propagation environments for physical layer secure communication. Next one, heterogeneous network. In general, heterogeneous network is the consisted of various types of networks which operates in the same system bandwidth. So next one, last, non-orthogonal multiple access NOMA. So one of the important element, particularly in 5G communication, a lot of research is going on, particularly in NOMA. So as a multiple access technology, the security of NOMA communication is an important concern which should be paid for more attention. So the physical layer security technology can be combined with NOMA to tackle this issue. The physical layer security NOMA is new. Okay. And last one, full duplex technology. The full duplex technology brings both the opportunity and the challenge for the physical air security communication. On the other hand, the eavesdropper with full duplex technology can actually attack the communication process while eavesdropping. In general, four categorizations of full depth physical air security communications are including. Yeah, okay. So these are the six techniques. Six. Yeah. These are the these are the promising 5G technologies we propose, and some other also are there. Finally, future technical challenges. Number of technical challenges for physical air security in 5G and beyond are LDPC actually codes with physical air security with coding is proposed. Physical air security coding, LDPC and polar codes, lattice codes may use. But here, LDPC codes for MIMO and massive MIMO systems when we investigated. This will be future challenge, future issue. We can work on that. LDPC codes for MIMO and massive MIMO systems can be investigated. Next on how to extend the polar code design. A lot of modification they are proposing polar codes to improve the performance for the 5G applications and beyond the 5G. So how to extend the polar code designs to more reasonable case where only channel distribution knowledge of the eavesdropper is available at the transmitter is an important research issue. This point also applies for lattice code design. Mainly in coding, we have proposed the LDPC followed by polar codes followed by lattice codes. And since massive MIMO is the key technology for 5G wireless network, secure transmission scheme designs for joint implementation of massive MIMO and other important 5G technologies. Earlier, only massive MIMO with physical air secure proposed. Now, combination will give the better performance. So the implementation of massive MIMO with other 5G technologies. Example, secure millimetric waves, massive MIMO communications, and the secure massive communications in heterogeneous networks. So combination will give some solution, some better solution for this. From the previous works, we can understand that the 5G technologies have their own benefits for security. So it is clear that if we combine more than one technology, it may increase the secrecy performance. We can work on that. These are my submission to the audience for the future challenges, particularly if you want to work with the physical layer technology. So mainly during this around 1 hour lecture, mainly we concentrated on the what is the basic principles proposed by Shannon to design a digital communication system. Particularly channel capacity, it's a very important parameter. Always to design a error-free communication or if you want to design a transmission with no errors, system with transmission with no errors, then you have to design below the limit, Shannon's limit. That is C is equal to C. Normally, limit may be expressed in binary digits per second, bits per second. So if you design above the limit, definitely. So whatever code you are using, advanced codes you are using, definitely that will raise some issues. Particularly, communication becomes slower. That may consume a lot of other fact a lot of, that may consume a lot of bandwidth, a lot of power, other things. Better you design below the limit. So that is the importance of the channel capacity. Then followed by wireless channel. Wireless channel is a time varying environment. So it is mainly due to when we are dealing with the wireless channel, fading is the one important element. Then we need to know how to tackle the fading and other parameters. Mainly due to mainly multipath. So with MIMO and massive MIMO, with the spatial diversity techniques, uh, spatial techniques, definitely it will provide some immunity against the fading and other parameters. Later, we have introduced secrecy and the cryptography. What is meant by secrecy? What Shannon has proposed. Later, why we are moving from why you are not using crypto systems? Why you are moving towards a physical layer security? Here, normally security is provided higher layers of the OSI model, but particularly at the physical layer. So it has a lot of advantages. And finally, 5G, 5G in particularly 5G, we are using 5G applications, particularly like banking applications, health applications. We are using 5G technologies. So security is the one of the important element. So with the advanced technique, already basically we are using coding and other things. Those techniques also will automatically provide a security. So, and in future, to improve better performance, definitely we can propose a combination of 5G technology. So with this, I'm going to stop my lecture. Actually, if you look at the references, all are Shannon's papers and other papers. This is my paper, what we proposed. what we presented in our IEEE conference, that is adaptive secret key generation in underwater acoustic system, particularly when we are dealing with the underwater channels. Instead of using electromagnetic, they are using acoustic channels. Here we proposed OFDM turbo code based technique. So with this, I'm going to stop. And first of all, I would like to extend my sincere thanks to Srinivas Rao garu, who has given me an opportunity to serve my institution. Thank you very much, sir. Thank you. We are grateful to you, sir. Thank you, sir. Thank you. Thank you. So now questions. Anybody having any questions, you can interact with me. We have enough time. Madam? And also I thank our honorable head of the department for giving me opportunity to serve my institution and my department. Hello?
Thank you, sir.
Thank you, madam. Yeah.
Thank you very much, sir.
కొద్దిగా ఎర్లీగా అయిపోయినా మేడం హేమ మేడం కొద్దిగా ఎర్లీగా అయిపోయినట్టుంది. యా
No problem.
Okay.
No, sir. Very nice session, sir. Your information is conveyed exactly. Thank you, sir.
Thank you, ma'am. Thank you.
Now I request Srinivas, sir. Srinivas.